Okay, let's continue working on more examples that will have more transformations, including the phase shift. So if we all look at example number 4, okay, where we have to graph y equal to sine brackets x minus a pi over 3. So right now we do see that there is a phase shift in this functions here. So again, when we before our graphing, we always want to make sure that we have all the details. So let's get the amplitude of the amplitude of the function, which is the absolute values of the a, and I do see that there is nothing in front of the sign, so that means the amplitude of a is equal to 1. I want to see what uh, the periods of the function is. So I'm looking for the k value. And the k value, since this is inside the psi, has nothing before the bracket. So again, the k value is also 1. And because k is 1, therefore, the period is going to be equal to 2 pi again. 2 pi divided by k, which is 2 pi divided by 1, is the same. So that will tell us that key points is going to happen every 2 points over 4, which is a pi over 2, same as before, okay? But because of the phase shift, I cannot just go ahead and give myself the 4 equal parts and label it as what I did with the previous 3 example, okay, because of the phase shift. So I'm going to show you another technique later on. So I'm not going to put any scale along the x-axis for now. Let's find out so right now I have the key points, and now I'm going to talk about the phase shift. So the phase shift D is going to be equal to positive a pi over 3, because if the phase shift is a negative, then you will see a plus sign in front. But because you see a negative sign in front of a pi over 3, so that means the phase shift, the D, is a positive pi over 3, okay? But you also must indicate the directions. So this is a pi over 3 to the right, because this is a positive, okay? And also we need to know the maximum, okay? Same as the maximum now. So because we don't have any c value, plus 0, so I know that the maximum is the absolute values of the amplitude 1 and plus the 0, so is equal to 1, okay? So I can go ahead and give myself the scale along the y-axis, and the minimum is going to be equal to the negative of the amplitude, so it's a negative the 1 plus the 0, no c, so you're getting a negative 1. So I will have to mark down here as my negative 1 right away, okay? So what else do we need? Well, equation of axis, okay? Equation of axis, which is the c value. So since there's no c, so that means y equal to 0 is going to be my equation of axis here, okay? Now, so the only thing left is to do is to how to set the scale on the x-axis, okay? Now, I need you to look at the two things that always that we want to make sure that how often the key points happening, pi over 2, and the phase shift is a pi over 3. I want you to look at that and this 2 number here, pi over 2 and a pi over 6, and get a common denominator between these two value. So the common denominator between a 2 and a 3 has to be equal to 6. So a pi over 2 here, it's just equivalent to a 3 pi over 6. So key points is happening every pi over 2, which is the same as a 3 pi over 6, okay? Because when you reduce it, you still get the pi over 2. But the phase shift, the pi over 3 to the right, in fact, is the same as 2 pi over 6 to the right. Okay, so now these two values here, I'm turning these two values with the same common denominator, which is the pi over 6. Okay, sorry, the denominator is equal to 6. So one is 3 pi over 6, the other is 2 pi over 6. So along the scale here, everything from now on is going to be under the fractions with the denominator of 6. So let's say if you have the first grid here, the first grid, let's say this is the first grid, then I will call this a 1 pi over 6. Okay? And then the second grid will be a 2 pi over 6. The third will be the 3 pi over 6. So everything along here will now be under the same common denominator, 6. Okay? The first one is the 1 pi over 6. Okay? Now, then think about the starting point now. Okay? Once we know what the first grid is going to be labeled on the graph, then let's start by finding out what is the starting point. The start point for the psi, and we already said it before, it is the phase shift as the x coordinates and the c. Okay, so in this case, we have a phase shift of pi over 3, but now we call this a 2 pi over 6. And a c is a 0. So I know that my starting point is 2 pi over 6. So which is this one here. Okay? So 0. So this is my starting point. Okay? So now I have well, if you don't, I don't really need to know the scale of the first grid, but I do need to know the scale for the starting point. So this point here is called 2 pi over 6. Okay? And then after my starting point, I know that key points happens every 3 pi over 6. So I'm going to count from the 2 pi over 6 here, 1, 2, 3 pi over 6. So that will give me a 5 pi over 6 for my next key point. So this is my starting point. My first key point on the side, if the A is positive, I should go up to the maximum. So I should be here. Okay? And my next quarter, I should have another key point, another 3 pi over 6. So from 5 pi over 6, 6, 7, 8. So the next key point is happening at 8 pi over 6. Okay? And 8 pi over 6. So starting from the middle, go to the max, then this second quarter, I should be back on the equation of axis, okay, at 8 pi over 6. Okay? And don't worry about reducing it. I don't want you to reduce it, the scales along here, because it's easier for us to keep track. Oh, how many pi over 6 am I getting the next key point? So from 8 pi over 6, another 3 pi over 6, I should be getting another key point. So from 8, so 9, 10, 11. So at 11 pi over 6, I should be getting the next key point, which is I'm coming down to the minimum. Okay? And another 3 pi over 6. So from 11, 12, 13, 14. 14 pi over 6. I'm back to the middle line again. Okay? So when I connect after the 4 equal parts, I can now slowly connect all the key points with a smooth curve. Okay? So this is my psi bracket x minus pi over 6. Okay? So that means from the parents functions, the starting points from the point of origin has moved pi over 3 to the right. Well, pi over 3 is the same as a 2 pi over 6, okay? With no up or down, but just the phase shift. So this is what I'm getting. So every 3 pi over 6, okay, from 2 pi over 6, you'll be getting a key point. So from here is 3, 4, 5, 6, 7, 8, and then 9, 10, 11, and then 12, 13, 14. So those are the only scales that I want to see, or I need to see as the scale for, along the x-axis. Okay? So maybe we can quickly do one more example. Okay, over here. So now we can see this one is has a little bit more than just the phase shift. Okay, so very quickly, let's look at this one. Again, I'm going to make notes of the amplitude. So now I do see there is a number in front of the cosine. So the absolute values of the A is going to be 3, okay? And the K values, do I see a K values now? Yes, I do see a K values after the cosine in front of the bracket, and make sure that the K value is always being factored out. If this one it has not been factored out, this one should look more like a 2x and plus is a pi over 3. Okay, if you see something like this, you always make sure that you factor the 2 out so that you will get a 2 bracket x plus a pi over 6 instead. Okay, so it is very important that if you if the question has not been fully factored for you, then please make sure you factored it out, because then you always make sure that the K values or the phase shift is actually what it is. So instead of a pi over 3 to the left, now you should have a pi over 6 to the left. Okay, so this is very important. So the K value is 2. So therefore, the period must be equal to 2 pi over the K. So it's 2 pi over 2, which is equal to pi. Okay, so now you have the periods of a pi. So one complete cycle is not 2 pi anymore. It got shrunk down a bit. So therefore, then the key points. So how often the key points is happening? Well, we always take the key points. We take the period, which is the pi, divided by 4. So we should get to see the key points is happening every pi over 4. Okay, we take the period divided by 4, because every period you always get 4 equal parts. Okay, and now for the phase shift, we do have a phase shift of pi over 6, but because the sign in front is a positive, so that means this is a pi over 6 to the left. So this is very, very important. Okay, not only that you determine how much that it has moved, but you also have to indicate that the directions that the graph is moving to the left. Okay, and so now the maximum value is the absolute value is the amplitude plus the C. Do I see any C here? No. So the C is 0. So you get the maximum of 3. Okay, so you can actually label this 1, 2, 3. And the minimum is equal to the negative of the amplitude, 3, and plus the 0, which is a negative 3. So you're getting 1, 2, 3 down here. Okay, so you can label this quickly. Now, when it comes to the scale on the x-axis, so again, I'm going to look into the key points and the phase shift here. okay? And try to find a common denominator between the pi over 4 and the pi over 6. And so I can change the key points. Instead of a pi over 4, I guess the common denominator will be all of 12. So this will be a 3 points over 12. So key points is happening instead of a pi over 4 is every 3 points over 12. Okay, because when you reduce it, you also get a pi over 4. So you haven't changed anything. And in terms of the phase shift, the pi over 6 left now is equivalent to a 2 points over 12, but also to the left. Okay? 2 pi over 12. It's the same as when you reduce it, it's the same as a pi over 6, but also to the left. Okay? So so that means along the x-axis here, I know that every grid that I put it on here, it has to have the denominator of 12. So this will be a pi over 12. Okay? Now, do I need to label this? Well, if you want to make sure that you know what the denominator for all of the scales is, yeah, you can label the first one here. But look at the start point first, okay? So we all know that the start point for the cosine is always equal to the phase shift, and it's either max or min. Well, in this case, it's going to be the max because the A is a positive. So we know that the starting point is going to be, the D is going to be a negative 2 points over 12. Well, the phase shift is pi over 6, but it's equivalent to 2 pi over 12. But because it's a left, then we need to put in the negative signs here. And the maximum value is 3. So I know that my starting point is going to be a negative 2 points over 12. So where's the negative 2 points over 12 is locating? Well, if I have a 1 grid here is represent the pi over 12, then 1 and a 2 on the left is going to give me the negative 2 pi over 12. Okay, very simple, straightforward. Okay, and the maximum is 3. So that means my starting point is going to be here. Well, let me use the blue to indicate. This is where my starting point is. Negative 2 pi over 12, comma, 3. Okay? And then from the starting point, then every 3 pi over 12, every 3 pi over 12 will give me the key point. So my next key points is going to happen from the negative 2 pi over 12. So 1, 2, 3. So it is going to happen at pi over 12. Okay? Oh, I forgot to label the equation of axis. So my equation of axis is going to be y equal to 0. Okay? Equations of axis is y equal to 0 because the c is equal to 0. Okay? So my first quarter is going to be 3 pi over 12. So from 3 pi over 12 from the negative 2 pi over 12 will be from here. 1, 2, 3. So it's happening at pi over 12. Okay, so since I start from the maximum, my first quarter is going to be down here on the equations of axis. Okay, and my second quarter is going to be another 3 pi over 12. So it's from 1 pi over 12. So 2, 3, 4 pi over 12. Okay? 1, 2, 3. So 3 pi over 12. So from 1 pi over 12 now becomes 4 pi over 12. I'm going to get my next key point. So starting from the max, going to the middle for the first quarter. Second quarter, I'm down to the minimum. Okay? And my third quarter is going to be another 3 pi over 12. So from 4 pi over 12, 5, 6, 7. 7 pi over 12 is my next quarter. I'm back to the middle line. And then my last quarter, another 3 pi over 12. So from 7 pi over 12, 8, 9, 10 pi over 12 is going to be my next quarter, which I'm going back to the maximum at 3. Okay, so very slowly, when you're going to connect all this point together with a smooth curve, okay, so this is your graph for the 3 cos bracket 2 times bracket x plus pi over 6. Okay, so basically your amplitude is going to be 3. Okay, so from the max to the middle is 3. Okay, and from the middle to the minimum is also 3. You're just moving it instead of starting from the on the y-axis, you're moving it pi over 6 to the left. So you're starting over here a little bit on the quadrant 2. Okay, and with the shortened period, because now the period is only pi. So the best thing to do is that when you're taking to make sure that you got the right period, is that since the graph ends at 10 pi over 12, when you take 10 pi over 12, subtract the starting, which is a negative 2 pi over 12. Okay, so that then you will get a 10 pi plus a 2 pi over 12, and you get a 12 pi over 12, which is the same as, which is the same as a pi. So now you know that you do have one complete period of a pi, from a negative 2 pi over 12 to a 10 pi over 12. Okay, so this is how you always double check to make sure, because sometimes when you miscalculate it down here, you might end it up with the wrong scale, okay, at the end. So this is a good habit that I always encourage people to do, is that when you always take the last scale, like in here, I have a 10 pi over 12, and the scale on the starting point is negative 2 pi over 12. When you subtract, take the biggest one, subtract the starting one. That is how you can confirm that you are actually getting a pi. Okay?